In this video, we're going to start looking at how to find the limit algebraically. So that means we're going to be given a function or an expression, and we are going to have to find that limit. So we're not going to be given a graph, we're going to be given an algebraic expression instead. So there's a few different limit rules. So just a reminder, when we're talking about the limit, when we're finding the limit of a function, we're looking at what is the y value as x approaches this value. So if I'm looking at the limit as x approaches 1 of 5, we're saying in this notation that our function f of x is equal to 5. And we want to say, okay, what is the y value of this function when x approaches 1? So if we think about f of x equals 5, if we were to draw that, that is a horizontal line through the y-axis at y equals 5, because the y value is always 5. And so if we're talking about what is the limit as x approaches 1, then the limit from the right and from the left of this function is just going to equal whatever that function value is, which is equal to 5. And the same thing is true for any constant. So if I'm doing the limit as x approaches 3 of pi, it's going to be the same thing. That function is going to be at 3.14159. So it's going to be where y equals that. It's going to be a horizontal line there. And as x approaches 3, my y value is going to be whatever that value of the constant is, which in this case is pi. So that's also pi. So when we're talking about the limit as x approaches c of a constant, I'm going to call this constant k, that's always just equal to k. And that's the limit of a constant. And a constant is just a number. Just in case you're not sure what constant means, a constant is just a number. So like 5 or pi is the number because it's 3.14 or 2 or -3 or anything like that. That is a constant. So then the next one we have is the limit of an identity function. So when I have the limit of an identity function, the identity function is y equals x, okay, or f of x equals x. And if we were to graph this function, we would get a line that goes through 0, 0 with a slope of 1, because when x is 1, then y is also 1. When x is 2, y is also 2. Like if I'm plugging values in here and making a table, x is 1, y is equal to x, so that's 1. When it's 2, it's 2. When it's 0, it's 0. When it's -1, my y value is also -1. So this is the line for y equals x. And if I want the limit as x approaches 1, then that value is just going to be the y value at 1, which is also 1. So the limit as x approaches 1 is just 1. And so what we did for this function is we just plugged in this x value, and that gave me the limit. And that's pretty much how we start doing limits. That's the first way we approach limits. So method 1 of evaluating limits is just direct substitution. So when I evaluate a limit, I can just plug in my x value that it's approaching into my function, and that will give me the y value of that function. So that will give me the limit, because if it's a continuous function, then the limit is going to equal whatever that y value is. Okay? So for any limit, what we just do is we plug in that value for every x, and then we simplify using our order of operations. Okay? Once you plug it in, do not write the limit. Limit is an operation, kind of like a plus or a minus sign. So once I do the operation, it goes away. So once I plug in that value, I don't write it anymore. Okay, and then just make sure we're following order of operations or plugging into calculators. So we do exponents first. So 2 squared is 4. I can do 2 times 2, which is 4. And then I have 3 times 4, which is 12 minus 4 plus 1. 12 minus 4 is 8 plus 1 is 9. So this limit is just equal to 9. Okay. And this will be the same thing. If I have the limit, the square root of 5x plus 4, what I can do is I can just plug in that x value for the x's and get the y value, and that will be the limit. Okay, so I have 5 times 1 is 5 plus 4 is 9, square root of 9, which is 3. Okay. And again, when you're plugging it in, just put equals and then put the values, don't write the limit. So that's the first way we do limits, and then we'll talk about a little bit more complicated methods in the next few videos.